Welcome back, everybody, for another webinar at Princeton for everyone worldwide. We're very happy to have Kevin Bryan with us from the University of Toronto. Hi, Kevin. Good to have you.
Hey, how are you, Marcus? Good to see everyone.
Hi, Kevin. Good to see you. Kevin will talk today about a user's guide to GPT and LLMs for economic research. Kevin was virtually at Princeton already some weeks ago, and he will tell us now how we can use GPT and ChatGPT much more widely for our economic research and outline various aspects to it. And before we start, give the floor to Kevin. We go to our usual poll questions, and thanks to all of you for answering the poll questions. Here are your answers, and Kevin will then illuminate us what the correct answers are down the road. First question was, does OpenAI's APIs do the cost to categorize 10,000 sentences from a historical business census, for example, and you want to discuss whether there's some adoption of new ideas or not? How much will this cost to you? Will it be $20, $200, $1,000, or $5,000? And the answers were 81%, 21%, 6%, and 1%. I give the answers away for this one. The majority is right with 81%. The second question was, does GPT improve productivity for humans and on which tasks? Will it help the weaker users to catch up with the stronger ones? Or will it help the stronger users to pull away from the weaker ones? So the high-skilled workers will benefit more? Or does it depend on the tasks? And will it work finally very autonomously? So it doesn't depend much on human skills at all. And the answers were 17%, 16%, 62%, so it depends on the task, was the majority, and 5% said it works very autonomously. The third question was about hallucinations, and we all know from GPT that there are hallucinations, and I guess Kevin will tell us how to control hallucinations with a more sophisticated prompting. Is it very common? But it can be fixed to 99%. That's, 48% said. It is impossible to fix. It's very common, but impossible to fix. It's 23%. Is it something very specific to OpenAI's GPT, or is it generally for LLM models, also for Google's and so forth? And that's what 17% said. Or is it a rare thing? And 12% thought it's a rare phenomenon. And finally, the last question is, what is LLMs or the large language models' primary advantage to research-intensive startups? Is it helping them to predict the market trends and consumer behavior? That's 23% thought this way. It allows the business to faster and more efficient decision-making. 42% thought this way. And it eliminates the need for human employees and cuts down on costs, 13%. And it can be easily integrated without disruptions in the business processes. That's 22% thought. There might be some truth to all of them, but we will figure out from Kevin what's the most prominent correct answer. But again, 23, 42, 13, and 22%. Finally, I would like to allude to another paper which by Anton Korenek he wrote, and he outlined a little bit how does ChatGPT and other large language models help us in research, in economic research. It's in different stages of economic research. One is the ideas by creating the idea, brainstorming with ChatGPT. You can have some communication with ChatGPT, get some more background research going as well. But it also helps a lot in writing and synthesizing some text, reducing the abstract from 200 words to 100 words, or reformatting the references, also just designing tweets afterwards to promote your research. But it can also help you in coding, especially in debugging, and explaining things and translating from one software language to another software language, data analysis, scanning OCR and getting some texture analysis out of text, so extracting some sentiment. And there are many, many things. There are many, many papers coming up, and I think we will learn today more tips and tricks how to do that. So with this, I will pass on the floor to Kevin, just to give you a little bit of an appetizer. And now comes the main course and the dessert from Kevin. Thanks again, Kevin, for doing it.
Great. Thank you very much, Marcus, for the introduction. I should mention, for the folks who know Anton Korenek's paper, It's well worth reading. I'm going to go into a little more detail on practical use of LLMs and how to avoid some of the problems that people sometimes face with them. But he gives a kind of much wider overview of tasks that go well beyond what I'm going to discuss today. So I recommend you take a look at that paper as well. I also should mention on our poll, so of course the modal response was correct on all 4 questions. The fun thing was the last question. We actually have a piece of software that I developed that we're using up here in Toronto that can automatically generate question banks for your classes. And I happen to have a class where we have a bunch of AI related documents that it's trained on. And so that last question was ChatGPT's question for you, not mine. Okay, I still agree with the answer though. All right, so let's get started. I'm going to open with just the very basics of LLMs. 5 minutes just to make sure we're on the same page. Then we're going to talk about practicality. So these large language models, essentially, I mean, they're really new. So there's a paper in 2017, a computer science paper named Attention is All You Need, introduces this architecture called a transformer that basically underlines all these large language models. This came from a team at Google, including actually an undergraduate here at the University of Toronto who was a summer intern at DeepMind. Was one of the authors on the paper. He's now started his own company. They just raised like $1 billion, a company called Cohere. So everyone's really interested in this technology, this idea. And it's simple enough, you can just read the paper and understand the kind of fundamental insight that they have. This is applied immediately to text and images with like so-so results. You were a little bit impressed, but you weren't like blown away until you start seeing GPT-3 in 2021. And then these image generators like DALL-E and Stable Diffusion in mid-2022, especially the latter, really impressed people. It just seemed like impossible for an AI to say paint a picture that's indistinguishable from, say, a painting by Van Gogh. But that's well within the capability of these models today. So we were already pretty impressed. And then November 30th, 2022, ChatGPT is released. And, you know, the entrepreneurship program I work with here at the University of Toronto, we've had a relationship with OpenAI for years. So we've had access to like earlier versions of GPT. We've had companies coming through who've been working with large language models literally since 2017 when the transformer was invented. And nonetheless, we were still amazed. Like we could not believe the step forward that we saw on November 30th. We're running back and forth down the hallway. Can you believe what this can do? And since November 30th, literally tens of billions of USD of market value have been created, funding companies in this area. Even though the VC market's quite weak at the moment. So companies like Cohere and OpenAI got a huge investment from Microsoft, Jasper, Anthropic, Stability, Midjourney, and so on. Okay, incredibly hot area. Everyone in the computer science world is aware of what's going on here. And if you're in our world in economics, you need to understand why they're so excited. Okay, so what can these LLMs do? We've had a few academic papers. Actually, most of the academic research you see on LLMs is pre-ChatGPT, which makes sense given that it's only 5 months old. So these are like kind of actually understating how amazing the technology is. But to give you 2 examples that might motivate you to think, I really need to understand this technology. On the right, I believe this is through GitHub's Copilot. They gave a bunch of people relatively straightforward coding tasks and gave some of them access to Copilot, which is basically a large language model that helps you interpret, debug, and write code. And the time it took to perform the task for the average coder fell from 2 hours, 41 minutes to 1 hour, 11. So like, you know, more than half the time to perform literally these people's jobs. And this is a randomized trial. On the left hand, we have a paper that looked at human salespeople who did or did not have access to essentially an AI that would suggest using a large language model phrasing on their sales calls. And again, you see just like the kind of productivity bumps that the customer purchase rate went from 2.8% to 4.5. Like this basically takes your kind of average salesperson and makes them your 90th percentile salesperson overnight. So we see these kind of results just over and over and over again in industry. From my perspective, you know, having worked, you know, I've helped run an AI-based entrepreneurship program since 2015. I've not seen a technological breakthrough as promising as large language models, I think, since the internet would probably be the last breakthrough at this level. So you really need to understand and understand how you can use the technology and what it can do for you as an economist. All right. So how do these things work? You sometimes hear large language models called stochastic parrots. That's true, but it's not negative. So for example, if I were to ask you, tell me what comes next, if I say the sun, and I ask Markus, he might say something like the sun rises, the sun is yellow, something like this. Okay, the sun shines. It's a beautiful day here in Boston where I am right now, and the sun is shining out the window. You can see it behind me. It looks like a cathedral. So, we've got some distribution of words that follow the sun in all of the written language we've ever seen. Okay, so imagine that prior distribution. And now think, what if I want to control writing so that it just doesn't pull like the kind of most common word, which is probably is, to follow the sun? What if I wanted to do something like say, change it to French, le soleil? Now the next word would be a, not is, right? So that'd be whatever is in French. And the idea basically of everything you're going to do with an LLM is you're going to try to adjust the posterior distribution of words that will follow words that already exist to get the response that you're trying to get out of the model. Okay, now it seems crazy. I admit it seems crazy that all you have to do, and this is really all that underlines most LLMs, it's not that much more complicated than this. We're going to take essentially the entire internet, okay? All the words. We're going to use this to predict the distribution of the next word from the words that preceded it. We're going to add a little bit of noise so it's not totally deterministic. And this trick is actually quite successful. And it might not be that surprising, okay? So let's imagine I gave you the following words. And I said, tell me whether this sentence is discussing foreign affairs or the economy, colon. The inflation rate rose to 3.2% yesterday, said the Fed, answer, colon. You would be able to say economics, right? And this sentence has never appeared anywhere on the internet, I'm quite sure. It's never been written by man ever. And yet, there's so much context here that it would be pretty easy for a model that could understand the structure of sentences implicitly by having foreign prior distribution based on all the words on the internet to know the next word better be foreign affairs or the economy, and to understand that the economy is more likely given some of the terms that we've seen here in the way they're ordered. Okay. So that's really all that's going on with LLMs. And we're just going to apply this to more and more complicated tasks. Now, what if I want to control it in the same way I can control, say, like a regression? I run a regression with a given set of data, it's going to give me the same result every time. Controlling an LLM is very, very difficult, is almost more of an art than a science at this point. But we do know, once we understand what's going on under the hood of an LLM, and from some research that's been done by computer scientists, we actually can control these things pretty well. I'll show you some tricks that will get the LLMs to do what you want them to do, that look very, very different from, say, just going to ChatGPT on the internet and typing something in and looking at the answer. So that's way, way, way far from the state of the art for the kind of task you're going to do as an economics researcher. The third thing that's important to fix is hallucinations or made up facts. Why do we make up facts? Well, literally all we're doing is predicting the next word on the basis of the words that have come before. We're not checking whether those words are true. We're not checking whether they have any basis. And so if I said something like, when I was reading Charles Dickens' novel, ... probably it's going to say a real novel, but, there are many people who've written fan fiction that are related to Charles Dickens. There are many kind of translations of the novels that we translated back into English don't look the same. It's not that surprising you might hallucinate given how LLMs work, but this is actually quite fixable. I would say in kind of the use cases I have, I just don't worry about hallucination. I'm able to fix it. So I'll show you how to do that. The fourth thing to understand, the rate of improvement is so quick that ChatGPT 5 months and 10 days ago came out. GPT-4 came out just over a month ago. Okay, so like everything I'm saying is subject to the kind of revision that you should expect from a technology that's moving that quickly. At the end of the talk, I'll give you some examples of things that will definitely be fixed soon. You'll be able to do with an LLM, and some things you definitely won't be able to do. But in between those polls, I'll be as surprised as you in 2024 what's possible.
You think, Kevin, that our publication process is way too slow to take advantage of that? Because my third revision of the paper, the technology will be totally outdated.
Yeah, of course. You know that luckily for economists, we have working papers that who cares about publications anyway, right? Once you have tenure, put your working paper on your website and leave it be. I believe it was Harsani, right, who eventually refused to submit any paper where he got referee reports. So you see his papers published in the most random journals because he was like, why should I already wrote the paper. You want to revise it, write your own follow-up. Maybe that's the way we'll have to go. Okay, and last thing to understand, when I say raw ChatGPT is far from the state of the art, what I mean is generally you're going to want to use the API, either for OpenAI or for their competitors, and some code. So that's going to give you just much more control of what's going to come out of an LLM. I'll show you how to do that. All right. Main research tasks that we'll talk about today that LLMs are really used for. The first one, entity recognition in unstructured data. So all the time we're trying to identify something. Like I was talking to Markus, you have all these old scanned documents. I want to know, when did mergers happen? In early 20th century Germany. And you give me like thousands of pages of text. I could read it and figure it out. It's not in any structure that's easy to deal with. So it's quite difficult for us we can't like run a regression. There's nothing we can do until we clean that data up. For structured data, where the form is well known, everything's like in numbers, there's probably better tools than LLMs, honestly, for most of those tasks. But unstructured data, the kind of thing where like you're going to hire some RA and have them just stare at stuff to try to figure out what's going on in this data, those type of tasks are really, really replaceable by LLMs. I'll show you a couple examples. Number two, if you're not already doing this, I'm just telling you you're making a mistake. To program anything is actually much, much faster using an LLM. In my case, for sure, like the doubling of code you can write in any given amount of time is probably an understatement. And this is true of not just like writing some Python or some R, but also true for creating like graphics for your papers, for example. You can do a lot quicker. The third use case is, we had spell check, then we had some spell check that can handle some grammar, and now you're like Gmail will correct you if you like, you get 2 words backwards. The kind of like improvement in your writing you can get out of an LLM is just way beyond that. So if you write clunky sentences and you want to rewrite it less clunky, you can just say, rewrite this in a less clunky way, it'll do it. Which is super useful, especially for people who are foreign language speakers that are writing not in their native tongue. The fourth thing that I use this for all the time is to summarize literature. So, a lot of us have a little folder on our computer with a bunch of documents, all these PDFs we read at some point, and we're like, I'm trying to remember what was the paper that did X, like what exactly did they find? And we scan through 20 pages and 20 pages and 20 pages. That problem is completely solved. I never do that anymore. I'll show you some code that will allow you basically to query in natural language like your entire folder of papers and just figure out the answer really quickly. What it can't do right now, but is coming soon, is correct math and derivations. It's just not sufficient for this task. Sometimes it gets it right, usually it gets it wrong. I'll discuss why. And more importantly, when we think through, if you know this idea in management called architectural disruption, that comes from Rebecca Henderson. Basically, when you have a big new innovation like this, replacing tasks we already do with kind of a cheaper, faster way is the first thing we wind up doing. But the really big long-term benefit of LLMs is going to be allowing us to do tasks that I can't even think of because we don't do them right now. And the reason we don't do them is because it was just not really feasible given the cost in the absence of an LLM. So what those tasks are, I have no idea, but I'm sure over the next few years, we're going to see amazing use cases. So don't think this is the limits of LLMs. Like any technology, we're very early. Okay. All right, let's go to how I can control an LLM. So there's essentially 4 ways to control the output of an LLM. And remember, all of these are doing the same thing. I'm going to take that distribution of words that are predicted to follow from words I've already written and just shift that posterior to the kind of words that I care about. So for example, let me hear a story. Tell me about the weather yesterday. The sun, ... So previously we were going to get the sun is, the sun shines, the sun rises. Now you're going to get the sun was, the sun shone, the sun rose, right? And why? Because following things like the weather yesterday, like in the English language, words that follow that kind of rough part of think of like the linguistic space, tend to be in the past tense. So this, just starting this little prompt and giving this prompt to an LLM will be sufficient to shift the posterior so that you're going to get something like the sun was here. Now, that's not a lot of control, but it's really, really easy. Second method, we sometimes call this like zero-shot context. And the idea here is we're going to give a bunch of context to the large language model about the kind of things we're interested in. So for example, I tell the LLM the context of our conversation are stories written by Ernest Hemingway. And then I say the sun, ... Now, an LLM to complete this is probably going to say also, which is where the sun rises. Sun also rises is the Hemingway book. And there's just no way it's going to choose the word also. It's a very unusual way to follow up the sun, unless you're literally talking about books by Hemingway. But this context is enough to shift the posterior so far that the LLM is going to say also in this context. Now we can give it even more context. Sometimes we call these few-shot prompting. So the idea here is whatever I want the LLM to do, I'm going to give it a bunch of examples of how I would like it to have responded. So for example, you can say something like example or user, the moon, answer, orbits 100,000 miles from Earth. These numbers are totally wrong, by the way, just in case you're wondering. I'm not GPT, nor am I an astronomer. Example, Mars, answer, orbits 50 million miles from Earth. Example, Pluto, answer, orbits 1 billion miles from Earth. User, the sun, answer. You give it this context, it is going to give you that the sun orbits 93 million miles from Earth. Now, again, that's a fairly unusual way to follow up the word the sun. But with this kind of few-shot context, it's just, I am 100% certain an LLM, any decent LLM is going to follow up the sun with exactly this sentence in exactly this way, if you give it this context. So this is a really common thing, like in industry, these kind of few-shot context prompting is probably actually the most common thing industry does to control their large language models. Finally, method 4, probably the one that seems the most natural is, okay, I train these LLMs on like the entire internet, say, or like all of Wikipedia, where it happens to be. If I want it to respond, say, in a more academic tone, why don't I just train the model on like academic documents, right? Then the way the model is going to speak, that posterior distribution of next words is going to look like the kind of clunky academic text that we expect. So for example, I could retrain or just train in an additional way. There's some really nice ways to do this that have come out over the last few weeks. An LLM on, say, a set of astronomy academic papers. And then if I say the sun, you might get something like the sun emits radiation or something like this, right? Those types of words are much more likely to appear in an academic paper about the sun than they are in all writing or all human speech about the sun. So this type of fine tuning, it doesn't require you to give a whole bunch of context. So if I've got use cases that look really, really different, but I would like to say answer in like an academic tone, fine tuning can be quite useful. Like one thing you often see this in industry is like, I would like you to answer using, say, internal corporate documents that use words in a very unusual way for the English language, but are very common inside a given corporation. So sure, fine tune the model. It's just probably too hard to give all the context I need on each question, and it's probably too expensive. So these are the 4 ways I can try to control.
So Kevin, can I just ask one question by Evik Cheney? She would like to know whether, you can ask LLMs directly how to better prompt more effectively the LLM. Is there some, loop essentially?
I would say this is a huge mistake. LLMs do not understand your question. LLMs literally are predicting the next word on the basis of your context, your question, and the following words. So it is not possible for, say, an LLM trained on writing from 2021 to understand what was done to program the model. Now it can give you a really convincing sounding answer to your question, but it will not know the answer. On the other hand, if, for example, I trained an LLM on a bunch of documents that we used to train that particular LLM, then I ask the question, then I'm sure it can give you an answer. But I certainly go ask GPT ask ChatGPT what GPT-4 does. It literally doesn't know because it was trained before GPT-4 existed. It doesn't know what GPT-4 is, but it's going to make up something very convincing to you about what's happening under the hood. So this is not a good way to use an LLM. You're just asking for hallucination in this case. Okay, so for these methods of control, the first method is like pure, just change the prompt. It's super cheap. It's often too imprecise for kind of research use cases. Fine tuning generally works quite well, but it's incredibly expensive. I mean, you would have a tough time fine tuning a model for less than 4 figures, and you would get bad results if you tried to do it yourself at that budget. So these ones in the middle, these contextual prompts, especially few shot contextual prompting, where few shot means give a few examples that are kind of drawn from the distribution of stuff you would like the LLM to take a look at. That turns out to work really well as a method of control, alongside some other tricks I'm about to show you. So, just a quick note, since we talked about cost in our initial questions, how much does this cost? So GPT, you can think of GPT as taking the entire internet. For all practical purposes, that's not that far off. The memory that it can hold on any given question, like when you're on ChatGPT and having a conversation, the memory being held is about 2,500 words at most. You cannot pay at any price OpenAI on the ChatGPT with this called GPT 3.5. You cannot give it more information on a given question, including all the context of prior questions. You get a conversation of more than 2,500 words. That's the most you can give it. GPT-4 has a bigger memory, but this memory constraint is really serious. So if you have like 10,000 pages of documents, you can't just give 10,000 pages of documents to an LLM and ask them to read it. That's just not how they work. They have very limited memory, so you need to use some tricks to be able to get around this. In addition,
but for the fine-tuning, the memory limit is it mostly for prompting or for fine-tuning? I don't have this memory.
Fine-tuning, there's no memory limit in the sense that, think of the memory as what I'm using to shift this initial distribution to some posterior.
Yes.
The fine-tuning just changes that initial distribution that I'm going to apply base rule to. So fine-tuning, in some sense, for like allows me to have like a bigger memory for certain things. So like, for example, imagine I had an LLM that was only trained on English documents. I could say explain some German grammar and some German words, but I'm very quickly going to run out of memory. Or I could just retrain the model on German documents, and then it's going to understand German. So for that use case, obviously fine-tuning is your only method. The other problem other than memory is that generally these systems, you can do some stuff locally, but the quality is much worse than the kind of best models, which are OpenAI basically, so GPT. If you use OpenAI, you're paying per token. A token is about 3/4 of a word. So it's not expensive. $1 gets you 500,000 tokens of responses and questions. But once you go up to GPT-4, that's a 15 to 20x increase in what you pay. Once you start asking questions of your own fine-tuned model through OpenAI, it's even more expensive. So, a 20x increase in your research budget, it better be a lot better for you to use that rather than just use some of the other prompting tricks I mentioned here today. The other thing you can pay for is, if you don't already pay for GPT-4 in like the chat This you can't really use for research because it limits you to 25 questions every 3 hours, and you can't use an API anyway. But it's $20 a month. I use it when I'm coding, I would say every day. So that's $20 very well spent, and you can just sign up for it and pay right now.
Can you just explain? So if everybody uses the chat, so everybody's familiar with the chat, but the other method you say, I write a little API program to plug it on top of GPT-4.
Yeah, I'll show you exactly how the code works. But the chat you have very little control. There's a lot of parameters underlying these models that are just fixed in the chat. If you code in, say, Python or wherever you want to use to call their API, you have to pay for it at about at $1 per 500,000 tokens. It's not that expensive. My lifetime spending with OpenAI is like $20, and I use it a lot. But you do have to pay. So there's no it's not like the kind of free ChatGPT you see on the internet, but it's really the only thing that's usable for the kind of research you want to do in some of these examples I'll show you. Okay, so.
And you didn't talk about the Google bot and all this. You will come to that as well?
So I won't come to it other than to say, I know people at DeepMind. Google has awesome internal stuff. I don't know if you saw, we're talking in mid-May right now. Google Bard just demonstrated, did a big demo yesterday, and it's embarrassingly far behind what OpenAI has released. And the same is true actually of what Facebook has put out. With the only benefit being that their stuff got leaked, so people are building open access LLMs on top of it. Right now, the only frontier LLM is OpenAI's GPT. Everything else is way behind it in essentially any task you want to perform. Anything you have access to, let's just say. So for all practical purposes, think of this talk as being about GPT. In 2025, who knows? I'm trying to be kind of agnostic to the exact technology, but I can't imagine any use case I would use Bard for example. Okay, so let me show you in practice how I do some of these tasks. So this is from a paper I was writing where we had to identify in patent text why a given scientific citation was used. So in particular, we are interested in, if you look at this paper by Barak et al. In the JBioChem, I want to know, is this citation referring to just general background knowledge? Is it a use case for the invention? Is it a tool or technique we use to make the invention? Why does this appear? And the reason we care, of course, is there's cheap citations that don't really mean anything, and there are citations that are super important to the advancement of science. And in the year 2023, we ought to be able to separate these things. And so we did a big survey. We have some ground truth, but surveys are expensive. Every single answer we get to a question like this costs us $40 US, 40. That's very expensive. So can we get an LLM to replicate some of this stuff, some of this analysis that we were just asking the inventor about? So you read this and you see ... We visualized these cells on a microscope stage as described in this article. They were then collected sequentially using this confocal microscope. Okay, so you would read this and you would say that's got to be a tool they were using when they were developing the invention. Okay, so how would I try to get an LLM to understand this? This is essentially all the code. In Python, I'm not joking. You can write this much code plus importing the OpenAI library and loading your API key, which is what charges you at OpenAI, but that's 5 lines of code. And then this, that's everything. That's all you need to perform this task in Python. And so what I'm gonna do is I'm gonna create one string called instructions. I'll show you what this will look like. And then I'll give this other string called patent, where I say the article in question is the Barak one. The patent text is that text I just showed you on the previous slide. And then I'm going to send this information in this structure to GPT's API. I'm using the ChatGPT, not GPT-4, just to save money. And here I set temperature to 0. Temperature to 0 means essentially I'm going to get deterministic answers. They're not going to be creative. It's not going to be what if Snoop Dogg wrote a rap song about, I don't know, game theory. That's the implicit temperature that you're seeing on ChatGPT when you use that website is not 0. It's much higher because it's trying to get creative answers. We're economics researchers. We don't generally want the creative answer. I want the as determinist as possible, as truthful as possible answer. So we take that temperature way down to 0. what instructions am I going to pass? Well, there's a few things I can do, right? So the first one, this is just a guess on something that might work. I'll say, consider the sample from a patent. We want to know why this data paper was cited by this inventor. Potential reasons are general background, a tool or technique, a use case. So I told this system, state first background knowledge, tool, technique, or example use. Then state why you think the stated article was cited by this inventor. Okay. So this is just a guess that this will work, just from some playing around that I've had, but I don't know. So let's try a second one. Here we go. The user wants to know why this data article was cited by this inventor. This looks very similar to you as a person, but in practice, these systems are a little bit of a black box, and minor changes in language can actually have pretty big differences in how the system behaves. So we'll try this one as well. And then let me try a few shot example. This is just, I kind of chopped this just so you'd be able to read it on this presentation on your computer. But here I gave, consider the sample from patent, and then I gave examples. User, article in question is Drew's, and then some patent text. And then I said, answer, this is background knowledge. The article by Drew's refers to the importance of GPT as a drug. User, the article in question is Ferguson, patent text, ... Response, tool, technique. This is used in the preparation of cells necessary to create a focal invention. And so in the full one, I gave a bunch more examples that were based on ground truth, okay? And if it were me and I was performing this task, I wouldn't like guess which one of these would work better. I would just use a trick that's well known to anyone who's used neural networks or machine learning, which is called an ensemble approach. The ensemble approach is, I'm going to ask all of these, and then I'm going to have the LLM vote, and I'm just going to take the most common answer. So this one, this particular text, I think is not going to be very difficult for an LLM to understand. This is like a tool or technique, but let's just see what it says, because I asked it for the explanation, so it's not even a black box. We'll get some idea of why the LLM answered the way it did. So here we go. These are the 3 prompts I just gave you and the responses. This number up here is how many tokens it cost me. So 495, 45, 724. So total, it cost me about 1,700 tokens, or 0.3 US cents to do this ensemble approach. And all 3 think this is a tool or technique, tool or technique, tool or technique, right? And they give, I would say actually all 3 of them give exactly correct explanations of why it's a tool or technique, like exactly what a person would have given. And so, you know, if I say did this for like 1,000 different chunks of patents where I want to understand why the reference is being used, I would guess most of the time these different prompting techniques are going to agree. And the ones that don't agree, I can take the majority vote of the different prompts, or I can say maybe I want a person to look at this on Mechanical Turk or an RA to clean up the data. Okay, so you don't have to agree. Yep. Can I also ask ChatGPT to give me a probability estimate which category it falls in? Yeah, or you can. You need to be very careful. Or even you can ask it how difficult is this to know. There are ways to write that prompt that generally do a pretty good job, but I found it's quite finicky. And I mean, I've seen some papers that like economics papers asking it like, what's the probability what's the variance of this thing given what the examples you've seen before. And it gives answers that look a lot like human subjects when you ask them to do the same task in, say, like a behavioral lab. So it can do it. This one, I feel like I've got total control. Whereas, and see, it's not total even. You see, like, it didn't give a colon here, it gave a period. And so there are things I would do on the back end to clean this up, even when the LLM's not exactly what I wanted to do, to still kind of understand tool technique is how it responded. So I wouldn't just throw this straight into a spreadsheet. I would probably like say, you know, given this first answer, how close do we think, is it like close in say letter distribution to one of the 3 answers I asked for? That'll be sufficient to clean all this up.
But okay. You can use the LLM again to go in the second step, no?
Of course, yeah. I'll show you a great example of when you use that in a second. Okay. I mean, how good is the entity recognition? This comes from a friend at Duke. He was at I think at the NSF, and they gave him this document of grants they'd given in the 1980s on an old floppy disk, and he opened it up in the file format. He didn't even know what it was. No idea. He tried to open the file in a text editor, and you can see it's just tons of things that you can like barely, it can't even interpret what the character is supposed to be. Like, how are you supposed to extract the data from this? He used an LLM to try to ask, like, what is the structure of this data? Can you figure out what the main things are? And once he'd done that, he asked the LLM extract those categories, and then he wound up with this. Okay, and like that came out of this. It's totally accurate. So for cleaning up really messy data, super good. I'll give you one more example here. I took this from, PDFs, especially economics PDFs, are like a giant mess, especially when you use LaTeX and you make a PDF. There's all sorts of well-known problems. Copying and pasting stuff just stinks. I don't want to pick on Markus, but Markus's working papers in particular are impossible to copy and paste from. So in any case, I took this paper of mine. It's got a little bit of math, and I OCR'd it, and then I put it into a little notepad, and you can see, golly, this is a giant mess. So for one, the LaTeX code has a ligature between the F and the I in a very common font we use that if you look up here on consider ? Has no idea what this ligature is supposed to be, right? And it happens a couple other times as well. Completely gets wrong. Like here it says 1 minus pi, even though it's 1 minus p sub I, okay? So it's a mess, right? And so in any case, I wrote a little code, very simple. I would say no more than like 20 lines of code to try to take text that looks like this and clean it up. So I ran it. This is what we get. I also had it write it in LaTeX for me. And this is perfect. Like,
well, but what do you have to do? You have to explain the pies now?
No, I did not explain. I didn't tell it that this should be an FI. I didn't say that the pi should be P sub I, but I did tell it the context that this came from. And the thing is, because it's an LLM, it understands the next word. So it sees, if PI are independent, right? It doesn't make any sense if pi are independent. And so it's going to think, oh, it's an OCR mistake. So it goes if P sub I are independent. I mean, this is perfect. Okay, this is the original LaTeX basically I recovered. So super useful for cleaning up messy text. You can see we OCR stuff all the time. It's a giant mess. It's much easier to clean it up this way than the other way. How about code? I'll give you a really simple one just because it's a fun one. Markus has seen this one before. So I'm just going to have the this is GPT-4. Give me the simplest Python code for a chart of supply and demand. I gave it demand as a function of price on purpose. Label supply, demand, label total surplus. Think step by step. This thinking step by step turns out to be quite useful for getting the correct response. Like it moves the posterior toward basically avoiding hallucinations. It's a nice trick for avoiding some hallucinations. And then create the LaTeX code. I type this in, output, here we go. Now, actually, the equations are all graphed correctly. The only problem is we're economists, and since Cournot, we put price on the y-axis, quantity on the x-axis, so it's not quite right. So I didn't bother to like redo all the code or anything. I just typed into the LM. That's pretty good. Remember that in the supply and demand graph, P's on the y-axis and Q's on the x. Also, make the axes go right to 0 on the plot. If you look over here, you see in the bottom left, that little annoying spot here. And when you're making your graphics, always some stupid stuff like this happens. You're like, oh God, what's the code? How do I clean that up? No, that's all a waste of your time. Look, I typed one sentence in natural language and it redrew the graph completely correctly. Okay. And if I wanted to change the colors and stuff, whatever, there's no point trying to create these graphs by like typing ticks or whatever you used to do before. The LMs are just outright better at this time. Summarization. So I told you that I'd scanned a bunch of papers from kind of my own personal database, and I used something called vector embedding. This is a little too difficult to discuss in the time we have, but you can think of this as 200 lines of Python and not 20, because it has to do a lot of stuff in the background. But basically, I can now query with an LLM like literally tens of thousands of pages of text. And so, I've got this paper with Mitch Hoffman and Amir Sariri that we did a field experiment, and I just said, give me the sample size, main methodology of the Bryan et al. Startup hiring paper. I didn't even tell it what the name of the paper was, and it does a bunch of stuff in the background to try to figure out where this context might be. gives all that stuff to an LLM. The LLM just rewrites the answer. This is completely correct. Okay, completely correct summary. And the cool thing, again, for people who are non-native English speakers, since our scientific documents are in English, but you might be more comfortable in their language, so don't worry. You know, for all the Germans here, the answer is completely correct. if you ask that question in German, you can get your Hauptergebnis and there you go. There's still 26 firms and 1,877 participants.
Seems like you learned some German in high school.
Ja, das ist schwierig, Markus. Keine Problem. Okay, so those are the main use cases. Now, practically, what do I want to do to make things as controlled and non-hallucinatory as possible? So, multi-step process is best. Do not open up the web browser and go to ChatGPT. Get yourself access to the API. Then you want to feed in data generally with few-shot prompting. The examples you choose should be drawn as widely as possible from the distribution of the things you want the LLM to understand as possible. Honestly, you can think about this as like you have an RA, you need them to like categorize some things. What examples would you give them that would like cover kind of all the broad cases that might come up, or as much of them as possible? That's what you want to give the LLM to, okay? Play around with the prompts. That ensemble approach I gave you works really well, so you don't have to like guess what the best prompt is. But just be aware, I've seen computer science papers where differences in prompts that are like trivial lead one prompt to match the ground truth 60%, another prompt matches the ground truth 99%. So for this reason, since we don't actually know in the computer science literature how to control these things fully and what optimal prompting looks like, I tend to think the best thing to do is use an ensemble approach. So it's so cheap to query the API. Just write a few reasonable looking prompts, test them out a few times, and then just have the LLM vote essentially on.
But don't you hit the memory limit more easily in the assembly approach?
No, because you're actually sending each prompt totally independently.
I see. Okay.
So I'm sending one prompt with this instructions, independent answer. One prompt with this instruction, independent answer, and then I'm just gonna look at the answers it gave and take the majority vote. Okay. Follow-up questions, and I don't mean in like a ChatGPT sense, but in your code are really useful. So, for example, if I send a bunch of context and I ask, give me the names of all the authors that appear here. It's going to give me some names. Sometimes it'll hallucinate, no matter how good you are at prompting. What I would do then is I would send another question to the LLM where I send, a user tells me that the authors in this paragraph are X, Y, and Z. This is the original paragraph. Are these users in fact in X, Y, Z? Answer yes, no. Okay. And this one's a pretty easy task. Actually, it's much easier than extracting the authors. And so if it says no, maybe you want to look at that on your own and double check. If it says yes, I'm feeling really confident it didn't hallucinate. And lastly, this temperature of 0 when you're using the API, almost all use cases that we care about in research, I would take the temperature down as low as you can. Like creativity is generally not what we want in our RAs or Mechanical Turk or whatever we're previously using. It's not what we want. We want people to code, so down to 0. Sometimes for like unusual coding, like if you code in Stata, for example, where there's much less content on the internet, it can help to bump the temperature up a little bit. It'll help the kind of the LLM figure out some aspects of Stata code that are not that obvious. But if you code in like Python, for example, and you want to ask some Python, code me this simple thing in Python, definitely temperature equals 0. There's so much that the LLM has read about how Python structure works from the internet that it's just going to get the answer correct.
So to understand the randomness of the system, so it doesn't always take the most likely posterior now, because otherwise you would always get the same if you ask twice the same thing. And so exactly. Temperature of 0 would give you twice. If you ask twice the same, you get twice the same answer. Or?
Temperature of 0, in my experience, always gives a deterministic answer. Mm-hmm. I understand from the computer science literature that it's not necessarily the case. It's not a guarantee. Now, it doesn't mean it's always true. It just means it's always deterministic. So these aren't the same thing. But unsurprisingly, deterministic and true are pretty heavily correlated for a lot of tasks, right? Okay, how do we handle limited memory? So one, break the task into different, break, say, your content into different chunks. So for example, if I want to search, say, a paper that I wrote, or like some legal document that's hundreds of pages for a particular thing. Like I would like to know, like in this giant legal document, say a zoning bylaw, what's the maximum height of a house in this city, okay, by bylaw. So if I was a person, I guess I can just control F this. Hopefully they say height. Maybe they say, you know, maximum elevation. Maybe, I don't know what they're going to say. So you might not find it even with control F. You can't send 100 pages of text to an LLM. So all you do is you break this text into chunks of 100 words, 200 words, overlapping them. You embed them, meaning you're going to take these like chunks of text and put them in like 1500 dimensional space, where chunks of text with similar meaning wind up in similar parts of space. If you use BERT or other similar embeddings, you're already familiar with this. It's an idea that precedes LLMs. And then you're going to take your question, like, what is the maximum height in this city? You're going to embed that also in the same space. You're going to do the dot product, the cosine similarity, to find the chunks of text most likely to be about the height of a house. And then you're just going to send all that to the LLM. You're going to say, LLM, here's a bunch of context from a bylaw. What's the maximum height of a house in the city? So now I'm only sending like 1,000 words to the LLM, but it's 1,000 words that were very judiciously chosen on my end. And the compute here to do all this stuff on your side is basically free, so it's not worth worrying about. So this kind of like vector embeddings to find the right context is generally the way that we get around limited memory. The other way we do it is if we have a database, we have the LLM write the query, the JSON query to query the database rather than passing the whole database to the LLM. These are, I think, not that complicated ideas.
But there are no packages which do this for you, or you have to program it on your own?
So the embeddings, like OpenAI has through their API an embedding you can use that's very inexpensive, you know, a few cents for a big PDF, for example. So I would just use that. I certainly wouldn't try to code this myself. If you're familiar with like BERT or similar kind of word embeddings or sentence embeddings, you can run that on your computer. It's a little bit slow. I just wouldn't bother because it's so cheap to use an API to do this. Yeah, that's right. And also this memory thing maybe is only a short run problem. It's not totally clear at a reasonable compute cost how much memory we can give these models. So like in 2025, will this be deprecated or not? I just don't know, right? It's possible we'll still have memory limits. Can it do math? No, the status quo is bad. Do not do math using LLM. It's just not good enough. That does not mean that you can't get an LLM to do math if you're clever. So, and here, I mean, even if you have access to the beta of the Wolfram Alpha plugin to GPT-4, it's still not good enough. So what I would do if I really need to do math is I would send the question to the LLM. I would ask it, are there any things that need to be computed? When I ask it that, I would say, write me Python code to do that computation. And then I would have my code on the back end, take any response that says, run this Python code, run that, and then pass the answer back to the LLM doing the compute on my side. So for example, like, think about how this works. Imagine I multiply two 8-digit numbers together. Those two 8-digit numbers have never been multiplied together on the internet before. That's not in the corpus of human language, okay? So there's no way that something just predicting the next letter or the next word is going to get the right answer. It is going to get the first 5, 6, 7 digits correct, because things that look kind of like the first number times kind of like the second number have actually appeared in the human corpus before. But it's not going to give you the right answer. Of course, this is so easy to fix. You just say, tell me the multiplication you want to do, and then I just pass it to whatever my favorite programming language is to do it. So there's many ways to get around the math problem, but it's still a bit of a problem. I mentioned already, I don't want to talk more about this. We don't know the way to optimal prompt. You can't like go read the computer science literature and understand like the right wording to use. Like it's all totally experimental at the right now. And ChatGPT is only 5 months old. 5 months from now, there'll be all sorts of new tricks that people have figured out that are better. But the ideas I'm mentioning here, like ensemble methods of LLMs, like vector embeddings to get around memory, all that is, I am sure, still going to be around a year from now, 2 years from now, 3 years from now. What's coming soon that we can't do? So OCR sucks. It's really awful having to scan old documents. They never scan really well. There are demos of LLMs reading images, reading the text off of images at really, really high quality. I suspect we will see LLM-based OCR in the next year that will be superior to PyTesseract or whatever it is you happen to use right now. Code, instead of asking the LLM to write you some code, then you pass it to your programming language, it'll just be able to run this in line as part of the LLM. You already have something called Code Interpreter. That's a beta with OpenAI right now that can do this. And obviously searching the web to verify facts, you can do this now. So if you find a fact, what you can do is use Google's API to search Google, grab the top results, pass that back to the LLM and say, is the fact that I want to hear confirmed by my web search? Okay, I mean, this is not hard. You can program it in, I don't know, 20 lines of code. But doing this automatically so that you can kind of pull facts in real time when you're talking to an LLM. Bing GPT is a little bit able to do this, though not very well. Obviously, this is the kind of next step. And computer scientists working on something called like information retrieval or knowledge graphs are combining the ideas they have in those fields with LLMs to do some really exciting things. So that's coming soon. All right, I want to make sure we have time for questions, so I'm going to pause here. I have a couple of little demos I'll show you if we have extra time, but otherwise let me give it to the audience and you, Markus.
Yeah, so there's some questions, perhaps we can cover them and then come back to the applications. But most of the questions are, you know, what you mentioned, all the advantages of the LLMs. Is there some risks associated with that as well? You know, so on the ethical side, can you use it in a malicious way? Yeah. That's one type of question. And where do you see the dangers?
Yes, it's interesting. There's like the long-term LLM risks that you know these kind of computer science folks sometimes worry about that come from some effective altruism web words. And then there's that are hypothetical and it's not obvious they'll ever come to pass. But then there's short-run worries that are currently possible and super worrying. So for example, it is very, very, very cheap to run, like think of like the emails that they would send to your parents, your grandparents, try to steal money from them, that were not that personalized. I can now run text messages where I respond using knowledge about you that I pulled off the internet, basically for free without even needing like a call center in India to do it. I mean, it's so worrying. Like when I talk to my folks, for instance, we have a code word so that if someone pretends to be me, this word's not on the internet. And if I say it, if they're not sure, I said, ask me for this word. And I would say this kind of thing, if you don't have it, especially with older folks you talk to, I would already be doing it. You know, for research, I'm not sure what the maliciousness is that I would worry about. I mean, it's generally like a super useful tool for teaching and for research through some of the cases I showed you today. But yeah, security. It's I mean, all the things that cost like $1 to try to scam people now cost a penny. That's obviously not going to be good. And we don't have good ways to stop that.
Another question was related to this is, you know, ChatGPT was using all this data from the internet. Should we treat this as a pool of a global public good, this pool of knowledge, and does it need some international regulations? So in the music industry, for example, they try to protect existing music.
I mean, it's a bit weird. So like, you know, I'm an innovation economist, so I study copyright as well. If all the people making songs today listen to other songs, that's how they learn to be a songwriter. It would be a little weird for someone to say, "Oh, you like the Beatles as a kid, and now you're Drake." You know, so Drake owes royalties to the Beatles. That's just not how we think about copyright. And similarly, like if I wanted to like learn German and I like, you know, read Die Welt, like I don't owe them money. Like, yeah, it's kind of a crazy question, I think. With art, maybe it's a little trickier because you're like building this system to allow you to like replicate the art in the style of a particular person. But again, if I was teaching art class and I wanted my students to make art that looked like, say, a particular artist, I would send them on the internet to look at what that art looks like, and then no one would say that I owe the artist money. I suspect that if you're famous enough that people will use your name to create new content, you're basically in fine shape. The LLM's only going to make you richer. The other thing I should also mention is that what we've learned is the initial training of these models uses tons of data, but we can get 99% of the result using much less, kind of a much more sparse set of weights. So that tells you most of the content was actually not really relevant, which probably isn't that surprising. And we're going to get a little better at learning what type of content matters and what doesn't. And then it won't be a problem. You don't want your stuff to be ingested by an LLM. Like, honestly, we don't need it for most use cases. So who cares,
So Justin Wolfers would like to know more teaching related. I know you've developed some teaching software as well based on LLM, but in particular is interested about, how should we assign homeworks to avoid cheating? Do you have some recommendations on this dimension too? Do we have to go to oral examination now and no more paper submissions? Or?
So this is a little bit of a different track. What you should be aware of is that it is not possible to know whether text is written by an LM. Even if a student doesn't change it at all, it's impossible to know. And if they ask the LM for ideas and for how to write the essay, and they just type it in different words, obviously you'll never catch them. So, we caught many people cheating in December using GPT at our university by having someone stand in the back of the room and look at their computers as they typed an in-person exam. So, I would expect anything that can be done with an LLM, the students will cheat because it's just very easy. In fact, we're all economists here. We understand substitution. You saw this company called Chegg, which is what your students were previously using to cheat in your class. Their market cap fell in half because it turns out that it's just cheaper to have GPT write your essay than someone in Kenya write your essay, which is what people were previously doing.
So there was a Princeton undergraduate student who wrote a senior thesis on a software called GPT-0.
Yeah. So it doesn't work. A lot of administrators think this works. So if you went to GPT and you asked it to write an essay on something and you took the results and you pasted it into GPT-0, it would say 99% this comes from GPT. But if you ask me to spend 1 minute to generate the same essay, I can get it to say 1% comes from GPT. And I'm sure the students are better. They can read Reddit also, and they know, literally take whatever you think GPT-0 is identifying and paste that back into ChatGPT. And the only instruction you type in is rewrite this so that the content is the same, but it does not look like it comes from an LLM. It's going to add a couple of spelling mistakes and a couple of things, and then GPT-0 can't find it anymore. So a lot of companies, because of things like prompt injection attacks and other security worries, are trying to solve the problem of when is this computer generated text and when is it not, and we do not have an ability to do this. So assume that if you give an assignment people can cheat on, the cost of cheating is now free, and so that's how much cheating I would expect to get. I would probably push evaluation to stuff I do in person. Or what I do in my class is you're allowed to use GPT however you want. You just have to, in the same way that you can talk to your classmates, you just can't have them do your assignment. So I ask you to, if you use GPT, to state exactly where you use GPT. If you use it for a spell check, you just have to state it when you hand in the assignment. Now, just like you could have cheated by having your friend write the assignment, but I don't tell you can't talk to your classmates, the same kind of norm needs to develop. And we also need the same kind of trust that we had previously, but that's basically all we can do.
So I know that you have developed some software for teaching, so there are a lot of questions about the teaching aspects, but do you still have time for these examples you wanted to go into? Or
sure. Do you want to see a quick one?
Yes, please.
All right, let's do this here. Just share this with you here. All right. So I need GPT to tell me, how do I open the PowerPoint back to the previous slide? Okay, so here's one, like as an example of something we're using in 3 classes right now that I wrote here at Rotman. Basically, think of this as GPT for your class. So all of our transcripts, our handouts, our slides, our readings, our optional readings are ingested into an LLM using, it's not fine-tuned because it's too expensive, but it's basically using this vector embedding idea I mentioned before, plus like lots and lots and lots of back-end code to make sure there's no hallucination and make sure nothing's no facts are made up. And so if a student asks one of these questions, like for instance, this for my entrepreneurship class, are ICOs, initial coin offerings, a good way for a crypto startup to raise money? In my class, I would have said something like, you know, in 2016, 2017, these were super common. People raised a lot of money with them. There's quite a lot of fraud. This led to a regulatory crackdown. More or less, it's dead these days. Even crypto firms are not raising money in this way. And so the student asked this, you type this into the internet, that is not the answer you're going to get. You type this into this system, I mean, it just says exactly what I just said. So it's just pulling it straight from the context of our lectures. So it allows the students essentially to have a 24/7 TA they can query, which is pretty useful. I also have another thing I wrote that lets you, using those same documents, auto-generate a question bank of like hundreds and hundreds of questions. And then you can just like chuck the ones you don't like, because some of them won't be very good questions. You keep the ones you like. And now you've got, you know, 200-300 question bank that the students can just, I want to know more about this topic. I don't feel like I understand it very well. And the cool thing about this is it's not just multiple choice where I give the answer and you say you got it right or you got it wrong. This is an LLM. So I'm passing the LLM a bunch of context about why it, like that it generated, about why it generated these options. So then when you give these answers, say you say like A, you know, like A here is like, what's a minimum viable product? Should be an easy question. And the student goes, launching a product with maximum functionality to gain feedback. So obviously this is like the opposite of what you want to do. Like an MVP should be like kind of a bare bones product in order to learn quicker about consumer demand for various features. And so this not only tells you the answer is B, it also explains why your answer was wrong and tries to give some explanation so the student can try to understand kind of what they're doing wrong.
So how is this different from Khan Academy's Mingo, which uses OpenAI to, you know, teach like a tutor?
Yeah, so very, very similar to I mean, the underlying idea is the same as like Duolingo Max or Khan Academy. I think mine was earlier. I built mine in March. But the thing is, like, this one is completely controllable for your content and for the kind of stuff you want students to have access to. So if I was teaching, like, say, Spanish 101 or like, you know, intro to algebra or something, I just send the students to Khan Academy. They have teams of engineers building stuff. But if I wanted to like replace a TA, I'm spending a couple hours training for like one of my classes, especially a class that's more qualitative, like theory of the firm or something like this. You just do this here and you basically have something that looks like Khan Academy. So this is, how hard was this to build? I spent 2 afternoons to make this, and you can just download it. It's on GitHub. You can do whatever you want with it. So this is like not complicated stuff, but will make a huge difference in teaching. And as we kind of get better LLMs, like once the mathematics ability gets better, say in 2024, 2025, and we can start using this to help students understand where they're making mistakes in derivations or understanding equilibrium concepts. I mean, it's going to be a game changer for how we can help students learn.
At this stage, it's mostly for things which are very word-based. So if you want to have figures in it or math in it, it will not work at this stage. We're not there yet.
No, I mean, you could, in the sense, like, I mean, I showed you that I can use the LLM to generate that supply and demand graph,
yes,
which was just created in Python. And of course, I can then just pass that to this is a web app using something called Flask. I just pass that figure to Flask. I just need more stuff in the background. So the LLM can't do all this itself right now, but if that's the feature you want, it would not take you a long time to be able to add that functionality. Yeah.
Very good. thanks a lot. I think we ran way over time today. But people are still here. So I appreciate it a lot. And we will do more on this line of teaching, because I think teaching will change dramatically as well. And we're trying to learn this. And Kevin is on the frontier on this dimension as well other people. So things are changing, things are moving. And as Kevin said, very fast. So very grateful that he brings us up to the frontier and how we can use it for economics. Of course, there are a lot of resources on the internet, but I think here's more focused on for economists and other social sciences, how to make a practical use of that. Thanks again, Kevin, and hope to see you soon again. Thanks enjoy your time in Boston.
And I hope it was useful for everyone else. Thank you.
Thanks, and thanks for everybody for coming. Talk to you soon.
Bye.
Bye-bye.